Okay, for this project, we're going to make a benchtop power source, and we're going to use a computer ATX power supply. I've got a couple of these. This one here is 480 watts total, but it'll provide some positive 12, positive 5, and positive 3.3 volts so that we can power switches, we can power lights, Arduinos. This will pretty well cover most of the electrical uses you might need on your layout. But I also see where it would be handy to have one set up for just on the benchtop. So when I'm working on locomotives or putting together lights and things like that, I've got a power source that's going to be the same as what I'm using on the layout. So these you can usually pick up pretty cheap, and I was fortunate enough that my grandson rebuilt a computer and pulled this out of his old computer, and it's still good, and it's got all your plugs and stuff on here. And my son-in-law, he had a couple laying around. He gave me another one that's got pretty good wattage on it. So what you want to do with these is you want to take and you want to cut off just all these plug-ins, because we don't use any of that. So we'll go through, we'll pull all the plugs off, and then we'll take and sort out the wires by the wire color. We'll group up all of our yellow, all of our red, all of our black, and then we have our other colors that'll provide the power on and off and standby. And we can even wire a couple of lights so we know whether it's on standby and it's receiving power, and whether or not the power is on. So let's take a look at the other one that I'm going to be using for the benchtop. We'll move this out of the way. We'll talk about some of the components we're going to need to do this. So I've got a board that I'm going to mount everything to. And this one, it'll be mounted for the bench, but I could take this and mount it over on the layout and use it on the layout. So you can see here, I've cut off all of the plugs, and I've taken all of my wires and grouped them together, my black, my yellow, my orange, and then I've got these other ones. So the green will be my power on-off switch. Purple is a standby, or the gray, and some of these wires I just won't use. Now this brown wire is what's called a sense wire, and this wire I'll have to make sure I hook it up along with the orange for that to be able to operate for 3.3 volts. But let's look at some of the other components that I'm going to need to put this together. So we're going to mount our power supply to the board, but then for the 5.5 volts, I need a 10 watt, 10 ohm resistor to be able to get my 5 watts of power. So we'll take one of the black, one of the red, and we'll hook up to this, and I'll mount this onto the cover so that way it'll dissipate heat, because these get quite hot. I need my terminal blocks, so I'll have separate terminal blocks power set up for the 3 watt, the 5 watt, the 11 watt, and then my ground. So I've got these terminals set up for that. And then between where they come in, I want to have fuses to protect in case we have any short circuits. So I've got one for the 12, the 5, and the 3.3. And we're using these regular glass fuses. The other thing I need is an on-off switch. So I've got a mini lighted rocker switch. So this is just power on and off. And I think that's about covers all the stuff I need. Oh, and if you want to wire lights, I've got a couple. I would use a green LED and a blue LED. So blue would be standby, and that just lets you know that you got power to the unit. The green is when you're operating power out through the output. So the first thing you need to do is go ahead and get this mounted down. Now this one has brackets on the outside, but it won't get it solid enough. So I did drill a hole through the case so I can get a screw in on this side. And you want to vacuum that out really well because you want to make sure no shavings get up in there to cause any short circuits. I also had the cover off so that I could blow any dust and stuff out of here and clean it up a little bit, and I just used canned air. I pulled the fan out, cleaned it real well, replaced it back in, so I think we're in pretty good shape. So we'll clear all this stuff out of the way, and then we'll get to putting this stuff together. Okay, now we just need to screw these down. Okay, good and solid. With that all screwed in, the next thing we can do is we need to set up our blocks where we want them. Let's get all our terminal blocks here. We can get this all laid out. So we're going to come in, and I have 2 sets of the black wires. So I think what I want to do is I want to terminate a set of ground wires here, and then we're going to terminate some 3.3 volt here, and that way we can run off of each of these. I'll terminate our 5 volt here. We'll set this up for the rest of the ground, and we're going to terminate the 12 volt here. So we're going to bring 12 volt down to here, and we're going to set our fuse in between here. We'll go over to here. Here's our ground running down to here. So then the next one we want is we want to set up a set of blocks here. So this half of this terminal block is going to be 5 volt feeding to this one. So we'll set our other fuse here. This half is going to be our 3.3 volt feeding to this block at 3.3. So we can set up the other one here. So that should work pretty good for all of our setup. So we just need to use our screws to get it screwed down to where we want them. Okay, we'll just start with a grounded block on the end down here. Okay, so now the fuses. Then we'll mount this terminal block up. And then we need to mount another fuse down here. And the last terminal block up here. Okay. So now all of our blocks are mounted. We get down to figuring out how to get the wiring all done now. So the other thing is we got to think about when I attach that, so I got to make sure that's done first. Okay, so everything's mounted in place. So here's the color chart I found online that tells us exactly what the colors on our ATX power supply mean. So of course the black is the ground, our orange is positive 3.3 volts, red is positive 5 volts, yellow is a positive 12 volts, white is negative 5 volt, blue negative 12 volt, and we're not using either one of those. The brown is our 3.3 volt sense wire. If there's a pink, that would be a 5 volt sense wire, and a small gauge yellow is a 12 volt sense wire. All the sense wires will be a smaller gauge wire. Green is our on, gray is the power good, and the purple is a standby. So now with our blocks and fuse posts all in place, it's time to work on how we're going to route these wires. So we know we want to route one set over to here for our ground. We know that our 3.3 volt is going to go here. We'll need to terminate these back here. Then our 5 volt terminate to here, so we'll need to terminate ends on these. Then our yellow has got to go all the way down. So some of our yellow is going to be a little bit short. Okay, we know our black's going to go here. Those break out there. These break out there. These yellows. So I may need to move this terminal block to be setting here. Let's go ahead and do that. Let's move this block so that we can. So if we move it up to about there, should be just fine. So now we know we can get these to here. Blacks will go to there, yellows to there, reds, oranges. Okay, let me grab some conduits here. Find my zip ties. Okay, I've only got a few small ones here. Forgot to pull a couple of these ground out, so I'll need one to go with the green, one to go to the red, and one for my standby. I'll need to keep those 3 out. So in the end, what we want is these to be all nice and neat. That way we can break them out as they go. But the rest of the bundle we want to keep tight. Okay. So we got a fairly good start on how we want them. So we need to look at, you're going to need to terminate all these wires. So these I can do a couple together, so I got 4. So 2, 2, and 1. This I got 4, so I got 1, 2, 3, 1, 2, 1, 2, 1, 2, and I've got a brown wire, which is a sense wire. So the sense wire needs to go in here as well. So that gets grouped up with my orange wires. There's no sense wire for the 5 volt. So we'll just start at this end. Let's get these all terminated first. So we're going to bring it around. We're going to put them in right there. So I'm going to want to cut these all off right in here. First I got to strip them. Two together there. Let's see, I want to make sure I'm not tangling these up too badly. Put these 2 together. And we're going to use, might be able to use these gauge, see if this fits on there. We're going to have to use our blue connectors. And we'll give a little tug just to make sure it's setting good. Grab the next pair and put those together. And then we'll get our last one here. Okay, so we can hook these in. Okay. Okay, our next set is going to be our orange wires. But let's go ahead and mount these down now. So not everything's not moving all over the place on us. Thread this through, get that brown one out of the way. Okay, that's going to hold those wires there. So now my orange. And we gotta remember we need a synth wire on this. And I don't fully understand it, but it's got something to do with the computer being able to regulate power. So this will not work at all if the synth isn't hooked in. So these will have to cut off right in this area. So here we've got 1, 2, 3 sets to put together. Actually, we can make these even shorter. And then our synth wire. Okay, so I'm going to put the synth wire on first because I want to make sure we do not forget it. So as you can tell, I'm no electrician, but I keep pushing forward and I'll get her done. Okay. Now we can hook these 3 in. Okay, so we need another clamp down because we want to make sure this all stays nice and snug. There we go, everything nice and snug there. Okay. Okay, let's get all this extra wire out of the way because we'll use this stuff a little bit later. Next one's going to be the reds. All right, so we got 2, 6, 8, 10 of these on the red. We're gonna keep one out for our resistor. So 2. Okay. So I just need to go along and terminate these. One more here. Okay. Okay, my next bundle needs to go right about here. I'm gonna hold that in place. About like so. Okay. So here I got 2, 4, 6, 8, 10, total of 12. Let's see which ones are laid out next to each other nicely. Yeah, it looks pretty good. These two are nicely together. These two are nicely together. Whoosh, all over the place. Okay. Start the termination. One. Look like they do pretty good. Gets a little more tricky when you got this many wires. So I can get them to lay together easily. I'm just going to go ahead and do them two at a time. Okay, there's two. There's one I missed cutting. Okay, the last one's right here. Okay. Now they're all threaded up. I got 1, 2, 3, 4, 5. So I got 1, 2, 3, 4, 5. Okay, I'm going to tie this one in right about here. Somehow I missed two. It's all right. We'll cut this off and do another one. Not surprised I missed a couple. And we'll just drop that one right in the middle. And it doesn't really matter where I'm hooking them up. There's no any kind of order or anything. I was just trying to group them all kind of spread out a little bit. And I don't think it really matters because in the end, we've got the bus bar on here that ties all of these together. So just grab another panduit here. Okay, now all we got left is hook up the yellows. Okay. Yeah, I think I cut these a little long. Okay, we're going to get all the debris out of here. We'll just turn it over. Okay, those two are going to be for the, these two will go for the resistor for the 5. One red, one green, one black for my on-off switch. And let me check my chart again real quick. That's the standby. And gray is solid good. So I want to use a gray. I'll need a gray and a black. And then these wires I won't use at all. So I'll just turn them and I'll group them all up together in there. But in the meantime, I just put a piece of tape on them to keep them out of the way. Okay, that'll keep those out of the way. And these two go together. And these two go together. Okay. So now I want to take and get my resistor hooked in. So this way we'll get a load on the 5-volt. Okay, and I've got some connectors I think will work for this. Hopefully these connectors will fit. Yeah, these will fit on there. So I'll be able to terminate these two. And that'll connect it on. Let me get my stripper here. There we go. It's gonna work. And the black one, approximately the same length. Strip it off. And we'll put our other spade connector on here. So my thought is we take and just mount it on top right here. We're going to make a mark. I'm going to make a mark right where we want this at. So we want it one corner there. One corner there. Okay, so now we got all these blocks hooked in. The next step is I need to get the jumpers to finish running the runs over through the fuses. So I've went ahead and made up some jumpers. They're just going to go in right here. And they just hook in right into these here. Put in there. And then the other end's on this side. Okay, so now we can see that the runs all the way, our 12 volt, all the way down through into our distribution block here. We have the bar in here that ties all these together. So all of these will have 12 volt power, every one of these positions. We can come out, our fuse goes here. And these are just the regular old glass, old school glass fuse. And these are, what did I get here? Yeah, I can't hardly read it now. So it's a 6 amp fuse. So now if we get a short, it'll blow my fuse instead of blowing whatever's going on down here. We don't need that down here, but we do have these we need to hook up. And this is our 5 amp power. And then we want to hook up down to here. And then you can see here we got the bus bar that connects all of these. So every one of this side will have 5 amps of power. Once again, to finish the circuit, we put our fuse in. There we go. Now we have a complete 5 amp circuit. Next, we want to do the 3.3. So we have a bar that connects these 4 positions. So we just need to connect in over there. Let's see, I think I have this one to go in here. Here we go. So then we need to come across from this side. And this is going to be our 3.3 bus. Okay, one more fuse. Okay, so then that means we're all connected up. 3.3, 5 amp, our grounds, and our 12. 3.3, 5, 12 volt. So we're all done monkeying about with all this. So we can just kind of tuck this all back in here. We're going to put the cover back on. Yeah, these are some little small screws. So I'm thankful that I have these magnetic trays to hold this kind of stuff in, because you saw the mess that we were making putting this thing together. Man, we get it everywhere. I'd have lost these screws for sure. Okay, we got this one on the side. And we hook up over here. This will provide a load. Oh, that's hard to get on here. There we go. Okay, 10 volt, 10 amp resistor provides a load for our 5 volt. So the next thing we need is we're gonna go ahead and set up our switch. Okay, for these, I need, I must have put them away. All right, here's our switch. Just on and off. Okay, this fits. We need to just put 2 of these on here. Okay, I'm not absolutely positive which ones you got to be hooked up, so you're gonna need to plug this in. So when I flip the switch, it's not lighting up, but I hear the fan running in here. So I know now we've got power. So let's test it out and see what we're getting here. This should be for DC. So 11.57. So let's check our 5 volt. $5.21. 5.22, that's about what I expected. So now we want to go over here and want to check our 3.3 volts. 3.22. Let's try it using the ground from this side. and 3.21. Let's try to set this where you can. Not sure how to set this up where you can see the readings better. There we go. All right. So if we touch here on 3 amp, 3 volt, reading 3.23 volts. Now we'll move over to our 5 volt, 5.21 volts. And now we're going to move all the way down to 12 volts. And our reading here we go. 11.56. All the way across the board. So it looks like everything's working like it's supposed to. Okay, so the only other thing that I really can do at this moment, we've got our switch set up here, is I could wire this up and set us up a light that shows when we've got power going into the unit. And I think what I can do is I can use this old bracket that I had. So we could use a blue light that's a standby, but just for testing purpose, I have another light that's already hooked up. So I'm just going to go ahead and use my white light just to make sure that the circuit works. So I can put the light in down here. Then I just need to connect up with the gray and the black wire. So let me do some stripping. What do I do with the strippers? Here we are. There we go. So this light would indicate, and I'm going to change it out and put a blue one. So this just indicates that we've got power coming into the deal. So if I shut off the power out, see how it goes off? Turn it back on. That lets us know the power's on. So I'll need to figure out something to mount my switch on here. And then our on-off switch seems to be working. So I'd say this one's a big success. Here we go. Now with our project complete, we've got everything all hooked up the way we wanted it. So we have all this usable power, 12 volt, 5 volt, 3.3 volt. We're all fuse protected for all of them. And I've got the lighting wired up. Now this power supply came with an on-off switch in the back. When you turn it on, now we have a light that'll come on saying, hey, it's power ready, it's in standby mode. Then we have our switch. When we flip our switch, now we have our light that tells us power is being supplied from the ATX unit to all of our terminal blocks. So now we have available power that we can use. So all of this came together and it looks beautiful. But I've decided it's just too big to use as a benchtop power source. But it's going to be perfect, and we're going to go ahead and use this out on our layout, and we'll be able to run all of our lighting, our switch machines, and any other power things we can come across, Arduinos, whatever. We're going to do that, but I've got a great idea for another project for a benchtop power unit where we can put a power unit together that'll go into the back of the workbench, and it won't take up so much space and supply all the power we'll need for testing locos, doing lighting, and all the various things that we might want power for. But I would say this is a successful project, and I couldn't be happier with how it turned out.